So this is review of linear equations. Yep.
Didn't you say when like it's a negative, well, if it's just if it's like negative 2x right here, wouldn't you just put it over 1? Like positive 1? Or would it
Yep, positive 1. I'm sorry I said lesson 3. I actually meant lesson 2. Lesson 3 is the one you have Friday. So we're talking in this lesson about two different forms of an equation of a line. The first one, as we mentioned in the last example, y equals mx plus b. And that is slope, intercept form, where m stands for the slope, and b stands for the y-intercept. So this piece of paper in itself is both notes and practice all in one. If you find that you write larger, feel free to have a piece of notebook paper handy to add or work through problems. If you're working out problems, though, I do ask that you would staple that to the back of this when you turn it in so I can see all of your work. So starting with number 1, we have y equals negative 2x minus 2. So the slope is, with the x, it's the negative 2. The x is not included in the slope, so negative 2 is the slope. And we put that over 1 if it's just an integer value. The b value is negative 2. When we're given the equation first, we start with the b value, so we put a point at the y-intercept. And from there, use the slope to find the next point. So we're going to go from the y-intercept down 2 and over 1. You could also think about that negative sign being with the 1 instead, where we would go up 2 and to the left 1. I only need 2 points to make a line. 3 points makes it a little more precise. So then I just connect the dots. Sketch a line. Number 2, I'm going to have you do that one on your own, but you might want to, I do want to point out when there's just a negative sign there, you want to slide a 1 in there. So the slope there is actually going to be negative 1. We're going to move to number 3. This one's not in slope-intercept form. This one's actually in standard form. We're not going to spend as much time focusing on standard form in this class, so we want to convert this to slope-intercept form. That's the easiest kind of graph when it's in that form. So I'm going to rewrite it over here to the side so that I have a little space to work. Slope-intercept form, we solve for y. So I'm circling the y to remind myself that's what I want to get by itself. So I'll subtract 2x from both sides. Negative 5y then equals, I could write this as 5 minus 2x, but since slope-intercept form has the mx part first, I'm going to go ahead and write this as negative 2x plus 5. Finally, divide both sides by negative 5. Negative 5's cancel and I have y equals. Now here, I need to apply the divide by negative 5 to both the negative 2x and the 5. That would be 2/5, so negative 2 over negative 5 is positive 2/5. And then I can write the x next to the fraction, or I can write the x in the numerator. It would be wrong to write the x in the denominator. So those are your two options, numerator or next to. And then the 5 divided by negative 5 would be a negative 1. Now that it's in slope-intercept form, I need to identify my two things. M equals 2/5. B equals -1.
Do you have to write the M equals and B equals?
So I'm going to start at -1, my y-intercept. From there, I'm going to go up 2 and over 5. So up 2 and to the right 1 over 5. And I could also do down 2 and to the left 5. Down 2 and to the left 5. Again, 3 points just gives me a little more guidance to make my line a little more precise. 2 points is sufficient. Number 5. Again, I want to solve for y. When I rewrite this one, I'm going to put the 8y on the left side, since it's going to end, that's where I want it to end up. And then the 32 minus 2x. All we need to do here is what? Yep. Divide by 8 on both sides. And again, the divide by 8 applies to 32 and to the -2x. So y equals 32 divided by 8 is 4. And then we've got the minus 2/8 x. I always want to simplify fractions. So not only am I going to simplify that to -1/4, right? Common factor of it 2. I'm going to put that first. So y equals -1/4 x plus 4. Let's go ahead and finish it. The slope is negative, so that negative sign stays with the 2/8, and now it becomes the 1/4. So it's -1/4, but we'll start at the 4.
Would it be too
It'll be down 1 to the right 4.
Oh, okay, the 4 is still positive.
So you can think about that negative either with the 1 or the 4, not both. So I could also go up 1 and to the left 4. You want to be sure to put arrows on your lines. We're drawing linear equations here, not just segments. We're going to flip it over. Number 7. Like I said, we're actually not going to focus a whole lot on standard form today, so I'm going to change this from standard form to slope-intercept form. Please change it. Because if you do slope-intercept form, but you leave this wording, that gets confusing. So change it, slope-intercept form there. And here is also slope-intercept form. In 15 through 22, we're going to do a different form called point-slope form. Anybody remember that? Raise your hand. Point, slope, okay? So I bet some of you could already tell me, for number 7, how to write the equation with the given slope and y-intercept in slope-intercept form. Raise your hand if you can tell me that one. For number 7. Maddie? Good. Y equals -3/5 x plus 5. You can do the same for number 8. We'll skip that for now. We're going on to number 9 and 10. And you're welcome. These are done for you already because I changed the instructions. Done. So moving on to number 11, we have y plus 4 equals -7 times the quantity x minus 1. To solve for y here, we'd first have to distribute the negative 7. So y plus 4, we're on number 11, equals negative 7x plus 7. And then just subtract 4 from both sides. So y equals negative 7x plus 3. You could do the same idea here for number 13, so we're going to skip that, leave that one for you. Number 15, point slope form of the line. Does anybody remember what that looks like? Do you want to try it?
If I saw it, I could.
Okay, so I'll just put it up here. Y minus y1 equals m times the quantity x minus x1. And that is point slope form of a line, where x1 and x1, y1, you can see those here, that would be a given point. And you already know m stands for the slope. That's the same thing as slope-intercept form. So similar to the number 7, you're just going to plug things in. They've given us x1, y1, and they've given us m. So you can label those. That can help. And then we plug it in. So y minus y1 minus negative 2, so that's plus 2, equals m, so that's negative 1, and then x, see how the x and y, they stay in x and y, just like in slope-intercept form, x minus x1, so that's 4. And that's it. That's point slope form of a line.
You just put in close up.
You don't.
Nope. Nope, that's point slope form. Done. We're going to do the same form for number 17. They didn't give us a slope, but they gave us 2 points on 17. What could we do? Anybody? Lotus? Okay. There's a way to count it. Tommy?
X1, X2,
Okay.
Y1, Y2.
Yeah, it has something to do with that. So you got us.
So what, 19?
So m equals what
Wait, are you talking about?
X1.
for 17?
Oh,
No, wait.
What goes on top?
is it X1?
X2 minus X1. Wait,
y2 minus y1. So the rise, that's the change in the y, over the run, that's the change in the x. So the slope, the formula, here's a formula. Some of you told me yesterday you like having a given formula where you just plug things into. This is our third formula for the day. This is the slope formula. Make sure you write that down on your papers. Remember, you get to use notes. You can use assignments for your quiz. Quiz is Monday. So I'm going to find the slope, label x1, y1, and x2, y2. I say x1, but I mean x sub 1. So the 1s and 2s are actually subscripts. So that's for your first x1 and y1, first point and second point. So m equals y2 minus y1 over x2 minus x1, so it's minus negative 3, which becomes plus, yeah. So negative 1 minus 2 is negative 3 over 3, which simplifies to negative 1. Now I've got a point, and I could choose either point. and I've got a slope, point slope form. So I have y minus y1 equals m times x minus x1, or plus 3. And that's it. We're going to do two more together, 19 and 20. It gets easier. I would say it gets harder up to 17 and 18, and then gets a little easier on 19 and 21 and 20. So 19 asks you to, again, write the standard form. Nope. We're going to write the point slope form. Through the given point and parallel to the given line. Does anybody remember the relationship between slopes of parallel lines? Antoine, do you remember the relationship between those two slopes? I see Mason's hand up. Mason? Same. Which is beautiful, because then we know the slope without doing any real calculations. So m will be 2/3. So now we have a point and a slope, and I'm sure you could take it from there. And then there's perpendicular lines. Does anyone remember the relationship between slopes of perpendicular lines? Brian?
They're opposite reciprocal.
Yes. I'm going to make a note of that because sometimes I forget. And actually, I only saw one hand when I asked, so you should probably all write this down. Perpendicular lines have opposite reciprocal slopes. Hello? Yes. Macy? Perpendicular lines have opposite reciprocal slopes. Don't forget it. I think that's one of those things that was in there you just forgot. So if the slope of a given line is -2/7, and we want the perpendicular slope, that would be what? Right?
7/2.
Good. +7/2. Remember, reciprocal just means flip it. So then you have the point and the slope, and you could make the equation of the line and point slope form. We did it. Reviewing linear equations, practicing graphing, slope-intercept form, point-slope form, formula for slope, relationship between lines that are parallel and perpendicular, a lot of things. But you only have probably 10 or so problems that you need to do, and that'll be due by the beginning of class on Friday, or if you're not here, it'll be due by the beginning of class on Monday.